like to just move us along. That's my job, to be the timekeeper. So first up, I'll introduce Rafaela, who will present on paper 125, and just take it away.
Thank you. Exploring the application of lean principles to construction supply chain. That's the title of my paper. My name is Rafaela Broft. I'm working as a supply chain management consultant for ARPA, a lean institute in the Netherlands, and I'm also a PhD candidate since a couple of months. In a session yesterday, there was this discussion about the role of a main contractor. There was even a discussion whether the role will maintain in a couple of years, whether he is actually a contribution to the supply chain. I think it's a logical thought because if you look at the expectations to a customer, etc., most of the project don't get delivered the way they were supposed to be. There's a lot of barriers in the collaboration on site. He is outsourcing everything there is in the supply chain, so you could actually say, well, he's adding zero value. There has been a lot of papers saying we should look at improvement of the supply chain. We should look at a change actually in mentality, and there's been a movement to supply chain collaboration. But a lot of papers actually say or don't write about successful implementation of supply chain management at the lower tiers. This is the lower tiers. The general contractor is acknowledged to have a central position. He's acknowledged to have the overview of the project. He's acknowledged to have influence on the quality and performance of supply chain members, so of suppliers. But somehow the implementation of supply chain management is not successful. It's slow. And the main reason we say is he's using it as a project strategy rather than a central strategy. But what is it that stops it from being a central strategy? And you get the answer often, this is the people adding value, but you get the answer often, well, it's because of the characteristics of construction. It's because of the fact that there's converging logistic to come on a fixed point. It's because it's temporary and non-repetitive. There's always a change in the parties on site. You have multiple and concurrent projects at the same time to manage. It's engineered to order, and you have two types of processes, batch processes and job processes. And these characteristics are seen as peculiarities. They're seen as something that prevents flow as efficient as in manufacturing. And previous research that I've done with Stephen Pryke, UCL, says actually that the main contractor could use the central position. He could use and take the leading role in implementing supply chain. But we showed that if he wants to do that, he needs to develop his activities, internal activities, and become more mature. He needs to help suppliers to become more mature, and he needs to help value creation, facilitate value creation on-site and off-site. This paper shows the journey of one step. Just one step to become supply chain mature. So what could you do as a main contractor to become and to help? It describes the advantages and effects of implementing value stream thinking and flow to construction supply chain. And it shows what is the effect on collaboration and what is the effect on the activities. That step, it's a step in like a production system design. It's a step, how could you organize your project? How could you do, what could you do, etc. It's an experiment. So what do we have? We have a study that involves a construction supply chain initiated by a main contractor. So a main contractor says, okay, I'm going to build long-term agreements with suppliers in key categories. So he has one collaboration with every category, etc. The supply chain is based in the Netherlands, so he's working there. He has one focus. So he focuses on one value stream and then designs it for the value stream. And in this case, basiswonen, which is in Dutch, is housing. We chose an experiment or a project of 40 houses. So one project, 40 houses, and we conducted an experiment. And within this project, therefore, we have two cases. One case done as an experiment, and one case as a traditional. And the case involves more houses. So one part has been done as the experiment, and one part has been done a traditional way. This is just for you an illustration of the object. So this is the product they had to execute. So you have to imagine that while doing the experiment and while doing the traditional building, there were semi-structured interviews on all levels. So the director levels, project leader levels, and the people actually on site. There were also multi-moment analysis, so you have to imagine that every minute of the execution there has been measured what has been happening. And if you put that into a table, and this is just a summary, but this gives an overview of, okay, what has happened in case 1 and what has happened in case 2. And this is just general for a discipline, but we have this information also on every activity that has been done by a contractor or by a subcontractor. So for example, if you see production of foundations, then in this case it's not only foundations as a total, but also all the sub-activities have this information. What is the lead time and what is the value waste ratio? How many employees were involved? What time did they start? What time did they finish, etc. In this table you can see, and that's the most important information, is that when you do it with case 1 is an experiment, it's continuous flow. So no single moment that the product is waiting. So at the moment that one activity starts, finishes, the next one continues. And that means that the product is finished in 20 days. The other case, traditional, has the batch thinking in it. If you execute it that way, it's 50 days. So that's the biggest difference in lead time of delivery of one project. Value waste ratios are written then. Value adding activities within the activities of the supply chain members remain the same. So there's not more value added in one case over the other case. Within the activities, the ratio is the same, but of course there's a lot more waste in the traditional case because the product is waiting in between the activities of the different parties. There's also information about dependency. We ask them and we explore who are you dependent on? What other traits, etc. So that's column 1 saying, okay, that person is on a critical path, so he cannot continue with the project unless the other member is finished or unless the member is going to continue. It gives the original batch. How would you build it normally? It explores all the barriers, etc., and the biggest type of waste. Conclusions, if you look at this information, is of course you have extensive information about all the processes. You could use it as a supply chain member, so how can I improve my own processes, because you know everything about waste and value ratios. But you can also use it as a supply chain. Where's the gaps, where can we improve? It also gives, besides the team building, etc., because you're dependent, you find out who are you actually dependent on, who's your critical path. And by focusing on one product, you get what Lean says, you get the learning loop. You continue to the next one, etc., and you have your learning. So I would say it's time for more experiments, because you get a lot of information. And I have one movie that just gives an image of what has happened. You could skip at a certain point when it's too long. same experiment is going to be conducted in half year also in hospitals, in parking garages, different housing project and apartments. So it's going to give us a lot more information about different types of value streams. There's two options. Either I put it on the background, or we skip to the time lapse. What is?
Time for questions now.
No. So we just put it on the background.
So, questions?
Question, Martin Maritiki from Sydney, Australia. How did you collect your data? Because really, for doing these sorts of experiments,